Hi everyone, my name is Sophie, and today I'm going to be teaching you about how we're going to find the total resistance of multiple resistors that are in parallel. So let me just start with a very quick overview of what we've talked about in past videos about how circuits work, how resistors work, and just basic concepts that you'll need to understand for this video to make sense. So these are just two examples of circuits, and they both have two resistors, R1 and R2, and I'll label this one R1 and R2 as well. The difference is that this one is series on the left, and this one is in parallel. And the way that you can tell that two resistors are in series or in parallel with one another is that in this one, you'll see that electrons go through one and then the other. Whereas in this one, if it goes through R1, there's no possible way it can also go through R2. So there's two separate paths that electricity can take. So today we're going to be focusing on how we treat two resistors or more resistors when they're in parallel. Now, as I've talked about in previous videos, when we're talking about resistors and circuits, what we're usually going to want to do is reduce it so that there's only one resistor. And to do that, we have to calculate the equivalent resistance. That just basically means we need to find the resistance that there would be in a single resistor if there was only one resistor. So essentially we're going to try and find the combined amount of resistance that this circuit with two resistors would have. And there's different equations based on whether or not they're in series or in parallel. Like I said, today I'm just going to be talking about when they're in parallel. And the equation for that is this. I'm going to write it. So 1 over R equivalent, which is the equivalent resistance that we're looking for, is the same as 1 over R1 plus 1 over R2. Now I'll show you an example of that calculation. Alright, so here we've got a circuit with two resistors in parallel, which again we can find by seeing that there's two paths that electricity can take. And we want to find the equivalent resistance, which I've marked here with these question marks. So, like I said before, the equation is 1 over R equivalent is 1 over R1 plus 1 over R2. So let's fill in the variables with what we've got in our question. So R1 is 3, and R2 is 5, and which one is R1 or R2 doesn't matter. This equation will give you the same result either way. So now we've got 1/3 plus 1/5. I'm going to multiply both the top and the bottom of this by 5, which is the same thing as multiplying by 1, so it doesn't change the value of the fraction. And then I'm going to multiply both sides of this by 3, and now we've got 5 over 15 plus 3 over 15, which is a lot easier to calculate. It's just 8 over 15. And that is 1 over R equivalent, so R equivalent is actually 15 over 8 ohms, or just under 2 ohms. A good way of thinking about how this is possible is by considering the metaphor of the different paths being like pipes, and there's a fixed amount of water traveling, so having more pathways in itself gives you less resistance. Now, this can be a little bit hard to grasp, because if you look at our initial R1 and R2, they're both higher than 2 ohms, so it might seem strange that when you combine them you get a lower value. But, like I said, if you think about it as the pipes, you can sort of start to picture why electrons traveling through either this path or this path will have an easier time than an electron that can only travel through one path. This drawing got a little bit messy, so I'm just going to recap on the next slide. So just to recap what I said earlier, when we're finding the equivalent resistance, we're finding the resistance that a single resistor would have that would be equal to the total resistance of the entire circuit. And the equation for that when they're in parallel is 1 over R equivalent equals 1 over R1 plus 1 over R2. And the metaphor that explains why the total resistance is less than either of the parts is that you can picture it as water flowing through multiple pipes instead of one pipe. you can see how that would be easier for water to flow.